Gadget UK here again. This is the MVS that was cleaning up on the last video, Neo Geo MV-1FZ. The board was pretty clean after I finished that last exercise. It still needs a bit more cleaning really, because can't really see from here, but on some of the the large surface mount packages, there's a bit of residue or something there. I think it's just from dirt from the environment, and it won't come off with just a bit of isopropyl. It needs some proper PCB cleaner. So I'm going to give that a blast. Still waiting for some of that PCB cleaner to arrive. In the meantime, the 161-in-1 cart arrived. Also did the stereo line out mod as well, so you can see a little bit of Veristrip board there with some 4 caps, 4 resistors on there to merge the 3 audio channels that come out of the Yamaha chip, whichever one it is. I forget what the part number is on that. Yeah, so it gave me the ability to test this. What happened is the first game I ran on this, it ran fine. It was it was starting to glitch a little bit. It was like I would run out of time on Metal Slug right at the start of it, and I thought, this is a little bit strange. And I moved on to the next game to test that, and that worked fine. And then I tried another game, and that started glitching. When I say glitching, it was like, it's things like certain cheats that you haven't even implemented would come on. You couldn't get hit from bullets and things like that. So I switched it off, switched it on, and then it started glitching even more. And what was happening is on the screen, I had a black screen with white bars across the screen, and sort of somewhere in the middle it was saying slot, said slot, and then some sort of spurious character next to it. So I thought, okay, something's gone wrong here. Is there a fault? And I thought, well, it's powering up okay. There's no faults reported on boot. So at this point, I started playing around with the dip switches, and they started working. That dip switch 1 previously would not work, and then it dawned on me. I thought, I think there's something wrong with the backup RAM on this. It's from what I've read, you do get these sort of weird glitches and things. So I needed to take the battery out anyway, which I did. I don't think you can see over there. Remove the battery, powered it up, and after that, I got a backup RAM. Now this isn't the original backup RAM message I got, because it's now got a UniBIOS in there, as you can see. So it's address 10. It's written 5555, and it's got back B255. So the lower part of that address, not address, the lower part of that word has come back okay, and it's just the upper. Instead of getting 55, we've got B2, and it's consistent. It's the same every single time, which is a good sign, because when you get that, you're probably dealing with either, in some cases it could be a damaged board. You could have a missing address line or a missing data line onto one of the RAMs, or from the CPU to the RAM, wherever. But I know that's not the case, because I checked all of the pinouts on that RAM, on all 4 RAM chips, just to make sure that my RAM was all connected successfully. And yeah, so following on from that, I thought, okay, well, I need some RAM, which I ordered, that arrived today, and I need a UniBIOS in order that I can skip past this test, which I can. If I press A, I'll show you. So there's no more. You would normally get like a work RAM error or whatever else after that if anything else was showing as faulty. And I'll show you what this is doing now. 99% of these games work fine, but if I show you, for example, Metal Slug, notice there's no start music. That's the first oddity. Starts okay, then you get a crash. Now this changes. If I was to switch this the UniBIOS into USA, the game will start, but what will happen is it'll say out of time, and the character will die right at the beginning. And it's only the Metal Slug games that behave in this way. Now I'm pretty sure there's nothing wrong with the system other than the backup RAM. I think what's happening here is, obviously at certain points particularly when you start a game, it will save to the backup RAM, and the minute it tries to do that, this is where the problems ensue, I guess you could say. So yeah, it needs a new backup RAM. I'm just going to take the cart out there, and I'll just show you the PCB before we start, and I can have a go at fitting these chips. Right, there's the backup RAM chips, these 4 here. I believe, but the address I'm given, you know, this is 010, very early address. It's probably going to be about that backup RAM 3 chip that's faulty. So I'm going to start by removing that one and putting one of the replacements on there. Obviously you can just see UniBIOS there in shot. That was dead easy to do, you know, just lift it out with a screwdriver, stick the new one in. One of the reasons why these you know, backup RAM is quite a common problem, as is, you know, Z80 error on some of the earlier boards. But the backup RAM, the reason why this is such, you know, is more likely to fail than, say, the work RAM or the video RAM. If you think about it, these chips, they're in use pretty much all the time. I know they're not being addressed all the time, but the very fact that you've got a battery on there, these are powered for, you know, considerably, in certain circumstances, considerably longer than any of the other chips. You know, while the machine's switched off at night, you know, for example, you might have 8, 9, 10, 11, 12 hours or more where these chips are powered, you know, when other components on the system aren't, you know, via the backup battery. And of course, you know, with any sort of electronic component, you know, if you read the tech specs for those that component, you'll find that there's you know, a maximum number of hours that the device can operate, or a maximum number of operations, you know, transistor number of switching operations, etc. So whilst these are not really switching as such, you know, you're not getting any address, you know, anything like that. They're just sat there being powered, you know, sort of toasting away for prolonged periods of time. And that's, you know, the other element there, that they're not got the same cycle that a normal chip would have, where, you know, it gets pretty hot, it runs up to, you know, its working temperature, and it's used for, I don't know, 8, 9, 10 hours, etc. And before it gets powered down and it has a time to, you know, that cooling down period where it's just not in use, etc. Gates and things, and, you know, even the power component of it is just there, switched off. It's not doing anything. Where it's not the same with these backup RAMs. They're just powered up all the time in a hot environment, you know, 24/7, 365 days a year potentially, for years on end. It's no wonder the backup RAM chips fail before, you know, the work RAM or any others. The others still do fail. You know, I see lots of problems where people say, oh, you know, my work RAM's failed and my video RAM's failed. Chances are it's probably already been through 2 sets of backup RAM chips already. But, you know, there's always exceptions to the rule. But I just thought I'd mention that is one of the reasons why these go, why it's a common fault. I mean, coming back to what I was saying about the Z80, the reason you get the Z80 issue, my understanding is on the older versions of these boards, where you have a dedicated Z80 processor, the board's actually marked Z80A, so it should have the 4 megahertz version of the Z80. But Neo Geo and the Infinite Wisdom decided to fit a standard Z80, which I think will run at 2 megahertz or something, so it's like it's overclocked. And that works, you know, but again, these things, like I say, coming back to the tech spec, look at, you know, the standard operational limits, I guess, and lifetime expectancies, etc. of these devices. You'll find that, yeah, you know, they may well have, you know, I doubt they probably have on the spec there that it'll go up to 4 megahertz. They might have, you know, plus or minus 10% or something. Yeah, I guess that, you know, it will run at 4 megahertz, but you know, you're accelerating effectively the wear of the thing. You know, the normal operation, they might expect it to, you know, have 100 million operations or something before it fails, etc. You know, 100. I don't know what sort of quantities these things have without looking at a proper tech spec sheet for one of these. But you're halving the life of it. You're probably more than halving the life of it, because, you know, you're getting higher temperatures in there. The temperature is obviously a factor. Temperature is one of the things that affects the operation of the silicon in there, and any other, you know, technologies to do with switching, transistors, gates and things within the device. They're gonna wear out faster. You know, there's more potential there for a failure point because of the increased temperature and clock speed. You know, because you're running it out of spec effectively. So that's one of the reasons why the Z80, you get the Z80 failures. It's been overclocked, it's been cooked, it's died. And 9 times out of 10 you could probably just replace that Z80 chip and you'd be okay. And if you did, I'd replace it with the Z80A. Interestingly enough, on this board there is no I cannot see a Z80 on there for the life of me, and I suspect that that's probably because it's probably merged in with one of the custom chips. It's going to be something like that embedded within there now, or one of the larger dies on that board. I'm not really sure, but anyway, yeah. So next thing I'm going to do, as I said, is remove that chip. If you're going to do this yourself, you're probably best off using qwik, really. Far easier than what I'm doing here. Although it's working alright, there's very minimal risk of doing any damage here, as long as you've heated the pin sufficiently and don't try and bend it when it's not desoldered. But these are lifting quite nicely. Don't envisage any problems getting this off. Of course, I don't really know whether it's just going to be RAM 3. The memory test is one of those where it tests until it finds a failure and then it just reports the failure. There's no sort of continue, which is the way I would have programmed it, really. You want to be able to test more than just the bit that's failed, in order to ascertain how much damage has actually been done. Is it both chips? Is it just one word of the RAM that's not right? Is it the full, is it a big block of RAM? Is it the full, complete chip that's failed, effectively? Right, blue tack is your friend. All you need is a little bit, really. Just get it perfectly aligned. And you can micro adjust it. That looks alright to me. And we'll just tack this one pin. Same on the other corner here. We'll tack this one pin now that it looks pretty straight. Move the blue tack. Two pins now. It's fine. That's it. The final part is to get some solder onto those pins. For this I'm going to use my normal thick solder just because it contains a lot of flux. I don't know if you're going to be able to see this or not. I've done. Okay, that was with the first chip successfully replaced. So same problem, different address. Instead of 10, it's D00010, which I'm guessing means I've probably got a fault with the second DRAM chip on there, SRAM chip on there. So I've got a spare for that. Same technique as before. I'm going to flood fill the other side of that. Heat the whole thing up all the way along. It's absorbing quite a bit of heat, that actually. This is where sometimes a higher temperature or a hotter soldering iron, there we go. Chip removed, you tidy that up in case I need to reuse it. And then we'll just use the solder pump to get rid of all this excess solder. It will take several goes. And I'll just clean that up now with a bit of solder braid, desoldering braid, I should say. Nice and slowly, not too much. You don't want to break any of these off the board. There we go, you can see that side's nice and clean. We'll repeat for this side. Right, watch them. Touching those resistors. A little bit more heat there on that pad, I think. There we go, nice and clean. And repeat the process for the other RAM. Obviously, the important thing is to make sure you get pin 1. I never mentioned that before with the last chip. Get pin 1 lined up properly. Chip nice and central, even spacings, even distance, I guess, on the end of each pad, just to make sure you get it bang in the middle. Use a bit of bleed sack to hold it down. And then fine adjust as required. That's fine, it's pretty central. I'm going to tack that pin down. Yeah. Down, tack the other side. A large blob of solder, that'll probably remove some of that afterwards. I always put a bit of pressure while I reheat these, just to make sure that your chip is as flat as it possibly can be. And then with your blue tack, tack the other side. Again, put a bit of pressure on. And you can usually drag this away, you know, do a bit of drag solder in there, drag the solder away, and it works well. Remove a bit of excess off that, that'll probably go of its own accord in a minute. If not, you can always use the desolder pump just to remove a little bit too much, or you've got a bit too much. Just tidy these up a bit as best as you can. One side done, the other side. Give this board a quick clean with a bit of isoprop. While also the board, just around these RAM chips that I replaced. Get rid of the flux. You can see now that's starting to look pretty clean. Let's just dry that off with a bit of paper towel. Really shouldn't have had the battery connected while I do this, but it should be alright. There you go. As you can see, it's not a bad job. They've come out relatively well. Those no damage, so that's the main thing. There's a couple of big solder blobs in there. Perhaps that needs a bit of solder taking off there, I think. But for the most part, they're all pretty clean. Right. So we've still got a fault. A few thoughts. The first thing is, you know, you've done. I've done in my case here, you know, some work on these DRAM chips, the backup ones. Was that work done properly? You know, we've got good connectivity there. Well, I can tell you with 100% certainty that every single one of the traces that, you know, sort of lead in and out from these two SRAM chips are fine. I found an article. I'll just show you part of it that I printed off. On the net, where someone was good enough to sort of list, I guess, all of the connections on these RAM chips, RAM chip 3 and RAM chip 4. So as you can see, this one here is dealing with RAM chip 3, and what I'm saying is pin 1 should go to RAM chip 4 pin 1, RAM chip 1 pin 1, RAM chip 2 pin 1, CPU pin 46, GU533. So, you know, as an example, let's say GU533, if I can find the damn thing, where is it? There you go. That's GU533. You've got pin 1 is marked in the bottom left there, 19, 20, 32, 33. So, you know, it's just a case of counting round and doing continuity tests from whichever pin you're on, well, in that case pin 1, you know, to wherever. If you get continuity, that's great, you can sort of rule that out. And I've gone through these, I went through this about 3 times just for my own sanity. There was only one connection that I could not find for the life of me because I didn't have access to a circuit diagram at the time, and that is here, this Q1 collector. Q typically is a transistor. There are, you know, you've got one transistor there, well, that says IC2. It's not that one. And interestingly enough, on the underneath of my board, as you'll see, there's no silk screen. I wondered if this was a bootleg, but I mean, it's got all custom, you know, it's got all the proper SNK custom chips, and the board's identical, so I don't think that's the case. I think it was either a glitch in manufacturing or a manufacturing cost cutting exercise where they just went, sod it. You know, we're behind on the production run, let's just not print the silk screen on the underside. But there are a couple of transistors, you know, that looks like a transistor. I thought that was a transistor, but I think on reflection from other material I've read that that's actually some sort of diode. And there's a couple of what look like transistors down here, but again, not marked, haven't got a clue which one's which. So anyway, that was the only point of connectivity I couldn't check. Yeah, looking at that, I did manage to find some circuit diagrams eventually, and looking at the circuit diagrams and a few other threads I've read, pointed me towards this chip here, a 74HC32, which is a quad OR gate. So you've got 4 OR gates in there. Now, I don't know whether you're familiar with, in case you're not, I guess this is people aren't familiar with OR gates and logic chips. Yeah, an OR gate, you've got simply 2 input on this particular type. You've got 2 inputs and 1 output, and it's as it sounds. It's it's logical. You know, that's where the the name of logic gate comes from, really. That if you've got one of those 2 inputs high, you know, one or the other, it will output a high. If both of them are low, obviously you get a low. So, you know, and again with OR gates, you know, it's either or. So if both of them, if both of them are high, you'll still get a high. If one of them's high, you'll get a high. If they're both low, you'll get a low. So I guess the truth table for that would be, you know, well, I've just explained it. Basically, if you've got 2 lows, you'll get a low. One, you know, at 1 or more highs will give you a high. So I've printed off, just for simplicity, I guess, the diagram of this particular chip. So it's as it sits on the board there now. And you can see they're not just to the left, so they're not just to the left. First OR gate is there, so you've got 2 inputs and 1 output. And again, so you've got the same thing all the way around. It's just 4 discrete little OR gates within that package. And of course you've got your ground and your VCC as well. So, you know, ground plus 5. And basically, using a logic probe, if you were to, you know, check the levels of these pins to determine whether they're high or low, you can also, you know, check the output and as long as this isn't happening in real time, you know, if these were flickering you know, constantly between high and low, and that was flickering between high and low, you'd have a hard time trying to work out whether it's doing exactly what it should be doing. But for the most part, you tend to find that these things, when they crash or whatever, you know, you get a CPU halt or whatever, and everything kind of grinds to a halt anyway. So it's always worth a stab, really, with a logic probe. And that's exactly what I did with this last night. I put the logic probe on all. I checked every single one of these gates, and I'll show you that now so you can see what I've discovered. Right, so we're powered up, we've got the error on the screen, got the trusty logic probe here, and all I've done with this is power it off the power supply. You know, you could put the connections on the board, but I may as well get a +5 ground there easily. So, and the way this works, obviously, you touch it on the board somewhere, and if it's high, you'll get a red light, and if it's low, you'll get a green light. So, there we go. So check pin 1. That's a low. Pin 2. That's a low. So we would expect a low because you've got none of them are high. and on the next gate we've got a low and a high. Oh, we should have a high, and we've got a low. So again, just looking at the diagram, pin 4 is an input, so we count across 1, 2, 3, 4. That's an input, definitely an input. It's low. The next one is definitely an input, and that's high, or you know, one or the other is high, so we should get high. And the last pin, next to last pin there, is a low. So clearly the second OR gate in that chip is not working properly. And I tested the other side as well, the other two are okay, so it's the second part of that. I'm looking at the diagram and also measuring continuity. That feeds, I think it's pin 20 or pin 22, I forget which, on these SRAM chips, which I think is the right enable pin. So, you know, I'm not quite sure how the timing, you know, how it actually uses that OR gate, you know, in terms of the originating signals that come in, because there's more than one. If I look at this, I've managed to find a circuit diagram, and if I look at the circuit diagram for that, I can see that 3 of the OR gates are kind of used in like a little mini circuit of their own, if you like one of the OR gates, you know, feeds into another one, and then it sort of joins up to the other one. So you've got a little bit of, you know, there's a bit more than just a standard OR going on there. You've got, I don't know, a series, if you like, of a couple of different ORs with at least two inputs, I think, from different places on the board. And obviously, that is the fault. I guess the final part of this, really, which highlights that you know, there was more going on than perhaps just an addressing, you know, a RAM, you know, an actual RAM or address type fault somewhere. Is, and this can help you diagnose all sorts of different problems, really, is actually looking at the data that comes back. So in my case, you know, it'd written 5555, and you could look at that and think, well, that's a strange bloody number to be writing, you know, well, why is it always 5555? And it's just the way that the memory testing routine, if you like, that's been embedded in these BIOSes has been done. And it's one of these, there's many ways you can do this, you know, memory testing. You know, typically when I write software to test RAM, I would tend to go through sequentially through all the bits, and then do different patterns. And what you've got here is pattern, you know, a pattern of every other bit, and it's probably a two-phase thing. It probably goes first bit, miss a bit, do a bit, miss a bit, do a bit, miss a bit, do a bit, miss a bit. So, and for anybody who doesn't know, you know, the way that this binary is interpreted, you've got 1, 2, 4, 8, 16, 32, 64, 28. For each of the bit positions. So, like say, you know, 55. These are hexadecimal representations, by the way. It's not decimal. Yeah, if you were to add these up, you're going to get 55 in hexadecimal. Obviously the first one's 1. You've got bit 4 sets, so that's a 5. So that's the first part of the 5 there, and so on. So you know, that's how you do it. You work up and count them up, and yeah, comparing what we should have. You know, we should have 55. We're getting B2. Now, let's say, for example, it was almost the same as that, but we didn't have a 1 there, we had a 0. Yeah, so obviously the value here would be very, very similar. Instead of having 55, we would probably get 54, and you would find that that last bit was, that last one there was a 0. When you get a problem like that, that's a good sign. Well, it could be still an indicator that the SRAMs are faulty, but if you get different, you know, if you get different addresses each time, and you get different values, totally different values coming back each time, that's probably an indication of it's the SRAM. But if you were to get, you know, one particular bit within here that's just wrong, that's an indication to, you know, that there could be something wrong with the data lines rather than the address lines. It could still be no, in fact, it'd be the data lines if you get that sort of problem. So it's always worth, you know, it's worth looking at what you actually get back here, and trying to just see if you can make any sense of it. Looking at, you know, converting it into, you know, you've got the hex value because the Neo Geo gives you that. Put it into calculator in Windows or something. Convert it to binary. You know, paste your output. Sometimes the calculator, well, not sometimes, every time, the calculator won't give you always 8 bits. It'll give you however many bits there are. You know, the sort of significant bits, if you like. So you could end up with 7 bits, and you just could remember it starts from the right, so you just append, you know, zeros to the left hand side. yeah, sometimes it's useful to do this. I probably always do that right at the start, really, to see if you can see what you're dealing with. And it's the same with the address range. When it gives an address range on the screen there for D, what is it? D0010. Again, it's useful information. Neo Geo's handy. It's got handy debug code built into the BIOS there, in the sense that it'll tell you, it relates to the backup RAM. But you could be looking at something like this on another system where it's giving you some sort of exception with an address and, sort of expected values, things it's written, etc. And that might be all you have. And sometimes, that address is pivotal in working out where the fault is, really. If you can go away and find, some circuit diagram schematics and memory map or something for that, equipment, you should be able to, certainly from the memory map, you'll be able to work out, where that address range sits, what piece of hardware it might be affecting, and that that can make all the difference. You can, whether you're looking at a ROM chip, whether you're looking at a RAM chip, whether you're looking at some sort of intermediate controller, an MMU or some DMUX type circuitry that sort of sits in between somewhere. It just points you in the right direction. You can start looking at the circuit diagram, then looking at the board, and trying to work out, what might be at fault, I guess. And with something like that, typically, you need to start doing what I've done. Use the logic probe. If you've got a logic analyzer, that's even better. You can get some really cheap logic analyzers now from Dangerous Prototypes. That's a fantastic website. I recommend going there. And I've got one of those. I just haven't really needed to use it because, and that was my next step on this, really, to get the logic analyzer out there. Stick it on the DRAM, on the address lines, on the data pins, and let's try and see what's coming back across in real time. But it does take a bit of time because you only got small packet, small capture sizes on some of those cheap logic analyzers, which means you can need to do things quite a few times, and you've got to start, focusing on what your trigger is and trying to change your trigger accordingly so that you get snapshots at different points in time. Because sometimes when it first, hits particular lines and things, it can fire your trigger and you don't quite get the information you want. You might want something a few milliseconds later, further into the boot process, etc. So yeah, they can be a bit fiddly to use, but it's worth buying one, especially one of the ones from Dangerous Prototypes, because they're so cheap. I think the one I bought was, it's only a PCB with a couple, it comes with like little clips and things that go on it, where you got, I think, 16 channel. 16 channels was pretty good though, and it's got, I can't remember what it is, something like a 1 meg capture window or something. It doesn't hold very much, but and it was about £20 or £30, very, very cheap for what it is. So it's worth getting one of those. It's worth getting one of those even if you just want to just learn a little bit and see what the signals look like that come out of these chips. And I'm kicking myself because my oscilloscope's in the loft at the moment. I do want to get it down. Because there are other things you should check, basic checks, like you get a dead system. You should always check your crystals, check your clocks, look at your schematics. Something else I considered about that 7.4 HC32, as I mentioned, we've got four OR gates in there. I was racking my brains last night. In fact, I went through all my inventory of stuff to see if I could find any OR gate chip at all. I've not got anything at all in stock, unfortunately, so I did have to order one. But one of the things you can do on some systems, if you get a fault like this, and what you do find that one of your gates, like this one's faulty, is see if all of the gates are used, because in some systems, you may well have one of these chips on there and only 2 or 3 of the gates are used. It might be a bigger package and there might be 8 in there or 16 or however many there are, but it's always worth checking, because if there's one spare, what I could have done in this case is just cut the 3 pins and use some really small K&RYFX jumpers across from the board contacts, and effectively routed it through another one of these gates. But all 4 are used on the Neo Geo here for that 74, U17, which is the 74 HC32. Another thing that I was thinking last night, you start to look at some of these things and you think, what is it used for? Because if you think about an OR gate in general, you've got 2 highs, you've got 2 lines coming in, and no matter whether they're high or low, whether one of them's high, you want an output. Yeah, if both of them are high, you want an output. If one of them's high, one's high, or two's high, you still want an output. And the sort of logic dictates, well, hang on a minute, you could get around this by just soldering both those contacts onto that contact, and then you're getting more or less the same thing. And the reason they do this is, it's a buffer. Effectively, it sits in between, the inputs and the output. And one of the reasons you would want to do that is it's probably being driven by one of the custom chips, probably one of these, maybe even the CPU. And the drive levels, something else you need to look at the tech specs for these. The level of the output that it provides, over a certain distance on the board, and depending on the current, they can't always provide what you want them to provide. The actual line, if you just look at it on a scope, you might find instead of a nice square wave. Sort of coming into wherever this goes to, you start to get problems with clock edges and things, and it starts to, the voltage levels just drops a bit or whatever, and those are sorts of problems. There's people out there who know a lot more about this than me. I'm not claiming to be expert at this. This is just my understanding. It's layman's terms. It's what I know, what I've seen works, and and this is just the way it is for me, really. Like I say, if you go on to, if you ask someone like Dave Jones on the EEV blog, he'll be able to give you a hell of a lot more accurate information than I could possibly ever give you. I'm not claiming to be an electronics guru here by any means. I'm a novice, along with many of the other people on YouTube, I guess, who watch my novice videos. So there's a few things you can do. And I guess the final thing you could do is, if I had found another chip, even if it had been a big, sort of dip package, quite large, I could have just temporarily, sort of sat it on the board somewhere, wired up the +5 and the ground, and streamed some wires to here, lifted those 3 pins or cut them, because it's definitely faulty. Cut those 3 pins off there, and just stream some wires on there, just for my own peace of mind, really, to test it and say, yeah, okay, that's fixed it. Plus, it'd be really cool to play it over the next few days. It's a bit disappointing that it's not perfect for the weekend, but there you go.